Hey everyone, Mrs. Spatola here, and we are going to go over some of the answers to last night's homework. We are on page 276, and let's follow along. Letter A, compare the number of boys who played soccer and jumped rope using the difference. Write your answer as a sentence as Maura did. So what you had to do was you had to go back, read the paragraph prior, and remember, in this unit, there are going to be more situations of reading and analyzing. So for equivalent ratios, there's going to be a lot more reading involved. And remember that ratios compare and order is important. So the answer, when I look at letter A, there are 6 boys who played soccer. And then I also notice that there are 2 boys who jumped rope. So in order to answer the question, we're going to compare, okay? When Maura compared, she used the difference. So an acceptable answer should be 4 more boys played soccer than jumped rope. She compared using the difference. On the other hand, letter B, compare the number of boys who played soccer and jumped rope using a ratio. Write your answer as a sentence as Cassie did. Cassie also, we notice, simplified her answer. Now, if you didn't simplify your answer, that's perfectly fine. Okay, she wrote, for every 3 boys who played soccer, 1 boy jumped rope. However, if you did write, for every 6 boys who played soccer, 2 boys jumped rope, that would also be acceptable. So we have a couple of choices here that you could have had. Hopefully you have one of the 2. Letter C, compare the number of girls who played soccer to the number of boys who played soccer using a ratio. Write your answer in 3 different ways. Well, I can see that the girls who played soccer were 4, and the boys who played soccer was 6. So in 3 different ways, it could have been 4 to 6, 4:6, and 4/6. If you simplified, that would be acceptable as well. Number 4, Abigail mixed 2 cups of white paint with 6 tablespoons of blue paint. Write at least 2 ratio statements to describe the situation. Can you write more than 3? They wanted to know if you wanted to write more. Just, you know what, take that out. That actually shouldn't even be in there, so you can just take that out. Can you write more than 3? Take that out. And here's an example using the word to. So 1 cup of white paint to 3 tablespoons of blue. 1 to 3 using a colon, 1/3. And lastly, 2 cups to 6 tablespoons of blue, 2 to 6, and 2/6. All right, let's take a look. Today's lesson is going to focus on equivalent ratios, and we're going to look at some tables and diagrams. Here we are on page 278, Unit 8, Lesson 2, Equivalent Ratios using Tables and Diagrams. How can you create equivalent ratios? We're going to, for now, we're going to skip over the do now, and we're going to get right into the lesson. What are equivalent ratios? Equivalent ratios, and please highlight and follow along, equivalent ratios are ratios that name the same comparison. Equivalent ratios are also called proportions. If you remember in our silly song yesterday, they gave the definitions of equivalent ratios as actual proportions. Okay, let's keep going. Ratio problems can be represented and solved using a variety of strategies, tools, and representations, including a discrete diagram, a double number line. Highlight that because that's something we're going to be using, which is really awesome. A ratio table, which we're going to be using, and even tape diagrams. Each tool has its advantages and disadvantages, and can be selected strategically. As you can notice here, boys and girls, there's a lot more reading involved, but it's just a discussion of some of the tools and the strategies that can be used to help us set up equivalent ratios. Let's continue. You can also find equivalent ratios by multiplying both terms of a ratio by the same number, so the numerator and denominator by the same number. Remember, does it sound familiar? Whatever you do to the top, you have to do to the bottom. And number two, you can also find equivalent ratios by dividing both terms of a ratio by the same number. Equivalent ratios have a multiplicative relationship. Okay, let's continue. A ratio with no common factors is said to be in, take a minute, what do you think that is? Somebody call out. A ratio with no common factors is said to be in simplest form. Let's write that down. So that would be simplest form. Write that down. Awesome. Let's take a look at an example problem. Number 1, Jessica is making a fruit punch for a birthday party. She is following the recipe below. Now remember, we talked about how important it is to follow recipes, and she's going to be making a cran apple fruit punch. She uses 2 parts of apple juice for every 3 parts of cranberry juice. Jessica combines 2 cups of cranberry juice. So let's look at that here. 2 cups of cranberry juice with 3 cups of apple juice. 2 cups of cranberry juice, 3 cups of apple juice. Did Jessica follow the recipe above? Explain and represent your answer. When you see the word represent, it's another way to say basically show your work. Show work or justify. Okay? So take a minute, pause the video. You're going to write yes or no. Did she follow the recipe above? Pause the video now. So when you think about it, in the recipe, Jessica has written 2 parts apple juice for every 3 parts cranberry juice. However, when she actually made the recipe, she used 2 cups of cranberry juice and 3 cups of apple juice. Well, what do you notice? They're actually mixed up. So what she did was she switched. She kept the 2's in the right place, but she mixed up the juices. So the answer then, did she follow the recipe above? The answer is no. And I'm sure her fruit punch tasted a lot different than the recipe. Okay, let's do some more practice. Ready? Let's go to the next page. At a playground, there are 8 children and 5 adults. Write 2 ratio statements. Okay, so they're asking you for this one to write 2 ratio statements. We said yesterday ratio statements are ratio, let's write this down, ratio observation. So a statement that you're going to make is an observation based on information given. Okay? So we can keep this very simple. 8 children, 5 adults. So we could say for the first one, for every, I'm going to keep it simple. 8 children, for every 8 children, you should be copying, for every 8 children, there are what? Yep, 5 adults. Okay, that's one way we could do it. What's another ratio statement we could make? And they're not asking us to write it in 3 different ways, by the way. They just want 2 basic ratio statements. We said yesterday, a ratio statement is an observation. So what's another thing that we could say? We could say, and basically just switch it around. Just basically switch it around. Okay, for every 5 adults, let's just switch it around. For every 5 adults, for every 5 adults, there are 8 children. Okay? And that's all you have to do. Let's go on. Letter B. Complete the table showing equivalent ratios and show the patterns. So basically here, boys and girls, this is going to be a table. This is a table, which you're going to be seeing a lot of in this unit. And tables can really be extremely helpful. And a lot of times it's just following the patterns. So it says complete the table showing equivalent ratios and show the pattern. So let's take a look here. So I see this is 8 and I see this is 5. Now I notice that this is blank here, but then I know I go to 15. So when I think in terms of patterns, what's going to happen is if I have one ratio or my first set, it's going to be, so basically times 1, I have 8 children and 5 adults. Now, what if I double that and I make that times 2? What do I get after that? So 8 times 2 is what? 16. 5 times 2 is 10. Now, if I go ahead, now I see 15, so I look like I'm counting by 5s for adults. 5, 10, 15. I could probably easily fill in the rest. So I'm counting by 5s, but let's just go ahead. I know this is times 2. Just double check. This is times 3. So 8 times 3 is 24. 5 times 3 is 15. So now all I see here for the top row for the children, I am counting by 8s. I am counting by 8s. And for the adults, I'm counting by 5s. So now I'm just going to fill in the charts. And a lot of this is just sequencing and patterns and skip counting. So this is for the adults. I'll do 5, 10, 15, and then I see 20, 25, 30, 35. For the children, I'm going to add 8 each time. So 8, 16, 24. Now times 4, and I could write this here, times 4. So 8 times 4 is 32. Then I have 40, which is times 5. And you don't have to write this all across the top if you know your number patterns. So then times 6 would be 48. Times 7 would be 56. And here, boys and girls, is a table to represent the equivalent ratio of 8 children to 5 adults. These are all equivalent here. Let's take a look at number 3. Number 3, a bakery fills an order from a company for a set of bagels. Yum. For every 4 raisin bagels, the company wants 6 sesame bagels. Letter A, describe what the ratio 12 to 18 means in terms of the bagel order. Represent this equivalent ratio using any method. And then letter B is going to be complete the table and show the pattern. Very similar to what we did in the previous problem. So let's go back and let's analyze this from the beginning. Okay, so I know I'm going to have to describe what the question for letter A, I need to describe what this ratio 12 to 18 is going to mean. So I need to go back and understand what the actual information was at the beginning. A bakery fills an order from a company for a set of bagels. For every 4 raisin bagels, the company wants 6 sesame. So I'm going to start off by writing that down. So for every 4 raisin, so for 4 raisin, and you can write this down, follow along. 4 raisin, they want to order 6 sesame. Okay, So I can see for my ratio is 4 to 6. For every for every 4 raisins, I need 6 sesame. But now they're asking me, what does this ratio 12 to 18 mean? So I have to think in terms of the bagel order. Represent this equivalent ratio using any method. Well, I think actually before I answer that, I am going to go down and actually complete the table because I know that tables can be really helpful to answer questions. And you can go ahead and do this. So let's look at the ratio table. So here I see I have my raisin order. For every 4 raisin, I have 6 sesame. And I can see that there are a couple of numbers filled out already for me. So I'm thinking that this is times 1 here. So if I double it, that would be what? Times 2. So this becomes 8. This becomes 12. Then if I go times 3, this becomes 12. And this becomes 6 times 3 is 18. And I think I see something right there. If I continue times 4, I know this is 4 times 4 is 16. 6 times 4 is 24, so I know I'm right. And this is times 5. And this is going to be 6 times 5 is 30. And lastly, 4 times 6 is going to be 24. And this is going to be 36. Okay, so I filled in my table. And all I have to do is answer the question, describe what the ratio 12 to 18 means in terms of the bagel order, and I can see that it's already been completed in my table down here. So basically, think about that. So how could we actually write it? It means that we can actually just simply say that the order was tripled. The order of bagels was tripled. So it was tripled. So what exactly does that mean? It means that instead of 4 raisins, I can actually go back here and do this, times 3 over 3. 4 times 3 is 12 over 18. And there you have it. Let's go on to the next page. So on this page, you're going to be completing these 3 problems on your own and analyzing, following directions, and being very careful with the wording. Number 4, we'll just take a quick look at number 4. The diagram below shows the ratio of broth to noodles that are used in a noodle soup. Already talking about food. So the broth is 3 blue, represented by the blue, and the noodles are represented by the, I guess like the gold color. So I notice for every 3 blue, there are 2. So let's just put a line. I just want to start you off. Put a line right there. That'll help you a little bit, okay? You're going to go through which of the statements are true, and based on what you see, you're going to answer that question, okay? Based on what you see, you're going to answer that question. For number 5, let's just continue. So you're going to be working again on these independently on your own. You got this. And you're going to just be reading and following the directions. So this is the rest of classwork for the rest of class. This is your homework page. This will be completed. Read the directions. Number 8 is a challenge. You have to really think about this, okay? So number 8, you're going to read. There were 36 students voting. John got 2 votes for every vote that Will got. How many votes did each get? Use the table to solve. All right, I just want to make a mention in number 8. For number 8, a lot of you will have different answers. But At the end, I'd like you to write this down. At the end, total number of votes, you're going to have 36 here, and you're going to have a certain number here and here. The numbers above are going to be numbers that you select. I would start with the first one, okay? John got 2 votes for every vote Will got. Okay, so you're going to put that information in the first row. And then other than that, you can actually, like we did in the other tables, or if you feel that you have all this extra space on the side here, if you feel you need to draw a different diagram, that's perfectly fine. Try your best to fill these out. This last problem is a challenge, but you can definitely figure it out. Okay, the ratio of the number of boys to the number of girls at school is 4 to 5. What fraction of the students are boys? If there are 120 boys, how many students are there all together? Use the tape diagram to help you. All right, so I'll just give you a little hint. For this one here for the boys, notice it's broken into 1, 2, 3, 4 categories, and there's 120. That's all I'm going to tell you. So for now, try your best. This is Mrs. Spatola wishing you a great day. And remember, always be kind.